We would like to now generally write an arbitrary complex number, z, in terms of a modulus and a phase. Now, let me remind you that when we looked at the complex number e to the I theta, what we did was we picked a unit circle because its modulus was 1, and any point on that unit circle, we had the complex number z equals e to the I theta. Because the modulus was 1, the circle was radius 1. So for an arbitrary complex number, let's draw our representation. So for an arbitrary complex number, let's choose the radius of the circle equal to the modulus of the complex number. And let's draw a circle with an angle theta. Then we can represent this arbitrary complex number as a modulus, the radius of this circle, times e to the I theta. And so that's how we can generally represent a number. We call this the modulus and the phase. Now, with this notation, we can do a lot of very simple things. So let's just start looking at that conjugate, not a great circle, but that's the conjugate, z equals, we said before, x minus iy. Let's represent that as a complex number. So the way we represent this is z bar is the same modulus as before, but we write it as e to the minus I theta. So what we're doing is effectively changing the I to minus I. That's what the complex conjugate means. Let's just use our Euler formula. This is cosine of theta minus I sine of theta. And so we see that this is just x minus iy in agreement with what we had before about the complex conjugate. Now, there's other operations that are much easier to do with the conjugate. Let's look at one in particular. Let's look at what happens when we take an inverse of a complex number. Well, that's written as 1 over modulus of z, e to the I theta. And if I multiply top and bottom by by 1, e to the minus I theta, and I use the identity that e to the a, e to the b is equal to e to the a plus b. So e to the I theta times e to the minus I theta is e to the 0 or 1. Then the denominator just becomes the modulus of z, and the numerator is minus I theta. So our inverse of a complex number does two things. The phase goes from a positive theta to a negative theta, but notice that the radius of the circle has changed. So if I wanted to, again, do one more representation of 1 over z, I would take a circle. If this was the angle, if this was our z, let's not put it on that circle, because there's a reason for that. Here, z is equal to z bar e to the I theta. Then if we want to represent 1 over z, we go to the negative angle. So here's theta. When we go downstairs, that's minus theta. And the length here is, the radius of the circle is 1 over the modulus of z. So whereas the complex number, the number z is a radius z, the inverse of z is 1 over the modulus of z. So that's the different representations for a complex number, its conjugate, and its inverse.